Hello everyone, this is our chapter real number and lecture number 2. In this lecture we are introducing the set of real numbers. So as we will take the notation this for set of real numbers. So take the set of real numbers and the operations additions and multiplication. Now for these operations the following properties hold in our set of natural number. So what are these properties? We are taking the set of real number with two operations. One is addition and other is multiplication. So look at the properties which the set of real numbers hold. A1, A2, A3, A4, A5. These are the properties related to the operation addition. So first property is for all x, y belongs to R, there it implies x plus y belongs to R. This is closure property. Fine. With respect to addition, R is closed. Second property is commutative law, which says that x plus y equal to y plus x for all x, y belongs to R. Means if we interchange the order, the output will not change. This is called commutative law. Third is associative law. In this we have for all x, y, z belongs to R, x plus y plus z equal to x plus y plus z. If we take the bracket either this way or this way, the value will not change, they are equal. This is associative law. And then fourth is existence of additive identity. So what is the additive identity? Property of additive identity is that for all element x, if we have an element, it is denoted by 0, such that x plus 0 equal to 0 plus x. Either you add this 0 from the right or you add 0 from the left. Both should be same. It will come equal to x. Okay. So this element is called, this 0 element is called additive identity. And the next is additive inverse. So what is additive inverse? For each x in R, there exists an element y such that if you add this element y either from right or from left, we will get this 0 is not simple 0, this means additive identity. Okay. This, if we get the additive identity by adding the element y from either from right or from left. If we are getting additive identity, it means the element y is called additive inverse of x. Okay. And what is the notation for this additive inverse? This minus x, and we denote that additive inverse of x is y. If such property hold for x, then we say the additive inverse of x is y. This minus x, don't confuse in this. This is a notation. This is a notion. See, this is notation for additive inverse. This is a notion for additive inverse. Okay. It's not simple minus x. This is the notation. If minus x is written, it means the additive inverse of x is y. Okay. Now, these are 5 properties with respect to addition. Now, the other properties m1, m2, m3, m4, m5, these are related to product, that is multiplication. So the set R satisfies closure property with respect to multiplication. It means if x and y are two elements in R, then the product will be in R. Commutativity, the same properties which holds for addition holds for multiplication as well. Commutative law is saying for two elements x into y is same as y into x. If you change the order, there will be no change in the result for all x y belongs to R. Third is associative law. If you take bracket either this way or this way, the result will not change. X into yz equal to x into y into z for all x y z belongs to R. This is called associative law. फिर there is the multiplicative identity. Multiplicative identity means for all element x in R, if there exists an element denoted by 1 and which is not additive identity. This 0 does not mean 0. This 0 basically means this element 1 is not equal to additive identity, and this 1 is not simply 1, it is the notation for multiplicative identity. Okay, and if such element exists in a way that x into product this element 1 either from right or from left, it will be same as element x into 1, 1 into x equal to x for all x belongs to R. This is called multiplicative. Then this one is called multiplicative identity. And now what is multiplicative inverse? For any non-zero element in R, if we can find an element say z such that if you product this element either from right or from left into x, you are getting 1. This 1 is not 1, this is basically multiplicative identity. If you are multiplying z either from left or from right and you are getting multiplicative identity, then this element z is called multiplicative inverse of x. Multiplicative inverse of x. And the notation for multiplicative inverse of x is x inverse. So this is not simple x inverse. This basically means multiplicative inverse of x. This is the notation for multiplicative inverse. The multiplicative inverse of x is z. If this property hold for any z, then we call this z is what? Multiplicative inverse of x. So we say multiplicative inverse of x is z. Then there is so look at these a1, a2, a5. These axioms basically related to only the operation addition. Then this m1, m2, m5, these axioms are only related to multiplication. Now there is another axiom which is called distribution law. Distribution law says that for all xyz belongs to R, x into y plus z equal to x into y plus x into z. Basically this distribution law combines both operation, addition and multiplication. Okay, so now look at these property with these axioms. The set R, what is the structure of set R with these axioms? So in algebraic language, if you consider the set R and the operation addition and the axioms a1 to a5 holds, then we say R plus is an abelian group, is in terms of algebra. And similarly, if you take the set R excluding 0, set R say if you are excluding 0, this 0 basically means additive identity. If from R you are excluding additive identity and then taking the operation multiplication, and the axioms m1, m2, m3, m4, m5, then this R minus 0 with multiplication is also an abelian group. Fine. So R is abelian group with respect to addition, and R excluding additive identity with respect to multiplication is also an abelian group. Now next is, if you take both operation addition and multiplication with R, then this algebraic structure with all these axioms, A1 with all these axioms, A1 to A5, M1 to M5, and distribution law. So all these axioms, these algebraic structures form a field. Okay, so this is the in terms of algebra. Now we'll see the order relation in R. Ordering in R, it means if you take any two elements in R, you can compare these elements. Basically the ordering relation means any two elements you can compare in R. So if we have two elements x and y which are distinct in R, so we can compare these elements. How? Either x will be greater than y, and which is denoted as x is greater than y. This is the symbol for order which is greater than, and either x will be greater than y or x is less than y. That means x is less than y. This is the notation for less than y. So if you take any two distinct element in R, then it is not possible that at a same time they are greater than and equal less than. So either one property will hold, either x is greater than y or x is less than y. So these are some following here are some axioms related to the ordering relation. So what are these axioms? Ordering relations. With respect to ordering relation, we have axiom 1, which is O1. I denoted it O1. It is called trichotomy law. So what is trichotomy law says? Trichotomy law says that if for any two elements in R, if you are taking any two elements in the set R, then exactly one of these properties will be hold. Exactly one. Okay, not even two properties, exactly one. Either x will be greater than y, or x equal to y, or x is less than y. So any two elements of R will follow exactly one of these properties. Second order law is transitivity law. Transitivity law says that if x, y, z belongs to R, then if you have the relation x is greater than y, and between y, z you have relation y is greater than z, it means this element y, x is greater than this, and this element y is further greater than z, then it will imply that x is greater than z. X is greater than z. This law is transitivity law. Then monotonicity for addition. Monotonicity for addition is we use very frequently in the problems, but we don't know that this is the monotonicity for addition. How? What is this property? If you have x, y, z in R, and suppose x is greater than y, then if you add this third element z both sides, that is x plus z and y plus z, then order will not change. We use very frequently in many problems, right? So basically this is what monotonicity for addition. Similarly, we have monotonicity for multiplication, but slightly a different condition on z. So if x, y, z belongs to R and x is greater than y, then it implies that now in multiplication there will be condition on z. If z is positive, then if you multiply both sides, then order will not change. Order will remain same. But if z is negative, then order will be opposite. Okay. So monotonicity for multiplication says that if x is greater than y, it implies that xz is greater than yz, provided z is positive. Okay. Now look at all these axioms, A1 to A5, M1 to M5, distribution law and order axioms. With all these axioms, basically how many axioms? 5, 5, 10, 11 and 4, 15 axioms. With all 15 axioms, the algebraic structure are, now consider all the operation, addition, multiplication and order relation. This algebraic structure is an ordered field. Now next we have some consequences of field axiom. So now till now we discussed field axioms and order axiom, which we basically use in real analysis very frequently. Okay, this group axiom actually we use in frequently in algebra, but in real analysis we use field and order axiom very frequently. So some consequences of field axioms are that additive identity in R is unique. Similarly, multiplicative identity in R is unique. Additive inverse in R is unique. Multiplicative inverse in R is unique. Means ऐसा नहीं हो सकता कि सेट ऑफ रियल नंबर्स में आपको दो एडिटिव आइडेंटिटी मिल जाएं या दो मल्टीप्लिकेटिव आइडेंटिटी मिल जाएं या किसी एलिमेंट के दो एडिटिव इनवर्स मिल जाएं या किसी एलिमेंट के दो मल्टीप्लिकेटिव इनवर्स मिल जाएं. दिस इज़ नॉट पॉसिबल. दे आर यूनिक. ओके. नेक्स्ट इज कैंसिलेशन लॉ फॉर एडिशन. Cancellation law for addition hold. What is this cancellation law for addition? Cancellation law for addition says that if you have three elements x, y, z and x plus y equal to x plus z, this hold means this element is fixed x and here adding y, here adding z, then it implies what? Y is equal to z. Simply we use, if you remember, you in calculation simply you use that we cancel x, right? So how we cancel x? We cancel using the property of field axioms. Okay. Addition. So this is called cancellation law for addition. Similarly, cancellation law hold for multiplication also. Cancellation law for multiplication is little bit slightly with additional condition. X into y, if we have x into y equal to x into z. So can we cancel x? Yes, we can cancel x, but with the condition x should be not 0. Okay? With this condition, if x is not 0, it will give you, we can cancel x and it will give you the result y is equal to z. This cancellation law we use very frequently, but now you understood why we can use cancellation law, because of field axioms. Okay. So the next consequence for field axiom is that we have to, this property satisfied, x into 0 is equal to 0 for all x belongs to R. So how can we prove? Actually I want to show the proof of this because it is interesting proof. So this looks very basic, that but nothing is, this is very trivial. X into 0 is 0. This is always we are studying, but how we can prove x into 0 is equal to 0 in R? So x into 0 is equal to 0 using the field axioms we have to show this is true. So how can we show? We have to basically prove x into 0 is equal to 0. We have to prove. So how can we prove it? Take left hand side, x into 0, right? Now x 0 ko we can write 0 plus 0. Why? Because of additive identity. 0 is an element of R and we know that 0 is also additive identity. So additive identity, so 0 plus 0 will be same element 0. So in this way we can write 0 is 0 plus 0 using additive identity. Fine. Now I can distribute it by why? Because of distribution law holds in R. So I can distribute it x into 0 plus x into 0, which axiom? Using distribution law. Fine. X into 0 plus x into 0. Here is x into 0. Now this x into 0, since we know that 0 is the additive identity, so this x into 0, this is an element of R. We can write it x into 0 plus 0. We can write. Okay. So why we are writing this? Because 0 is additive identity. Fine. Now since we have seen in the last result that cancellation law holds for addition. Now we use cancellation law. By using cancellation law, we can cancel this term, first term, which will give you 0 x into 0 using cancellation law. Fine. Hence we have proved x into 0 is equal to 0. Okay, fine. So in this way, these small these results which are looking very trivial, but we have to prove it by using the properties of real number, field axioms of in real number. So the next property is that we have some other properties also. We'll see. We can see it. 8th property is saying that if x and y two elements in R, then x into y equal to 0. It implies either x is 0 or y is 0. So how will we prove it? Either x is 0 or y is 0. How will we prove? See, if x is equal to 0, we have to basically, what we have to show, we have to prove x into y is equal to 0 implies x is 0 और y is 0. ठीक है, ये हमें प्रूव करना है यूजिंग फील्ड एक्सियम्स, और जो भी अब तक हम कॉन्सिक्वेंसेस प्रूव कर चुके हैं फील्ड एक्सियम के, उनको भी हम यूज़ कर सकते हैं. तो इसको कैसे करेंगे? इफ़ x is non-zero, so if x is non-zero, sorry, not non-zero, if x is 0, if x is 0, then we are done. If x is 0, then 0 into y is equal to 0. We are done. Using seventh property which we have shown just now. If x is non-zero, if x is non-zero, it means what? X inverse will be exist. There exists x inverse in R. Okay? Because we know R is field. So if for all non-zero element in R x, there will be multiplicative inverse, and it will satisfy the property x into x inverse into x is equal to 1. That is multiplicative identity. Now we have to show xy is equal to 0 implies, so let us assume xy is equal to 0, that is given left hand side xy is equal to 0, and we have to show either x is 0 or y is 0. How can we show xy is 0? Just since x inverse exists, we can multiply x inverse both side. Fine. Why we can multiply? Because it is guaranteed that x inverse exists in R and x is non-zero. Because x is non-zero, so it is guaranteed that x inverse will be in R. That is why we can multiply x inverse by x inverse both side. Fine. Now here in the left hand side, use associative law, x inverse x into y, and this is x inverse into 0 will be 0 using the seventh property. Seventh property says that for every x belongs to R, x into 0 is 0. So using this property, x inverse into 0 is 0 by this seventh property. Now since x inverse into x is what? 1. So this is 1. And 1 is what? 1 is multiplicative identity and y is an element of R. तो multiplicative identity की property क्या होती है? If you multiply the element, you will get the same element. Y is equal to 0. So in this way, we have proved y is equal to 0. Okay. Similarly, we can prove the other way. The next ninth property is that hence we have proved eighth property, eighth consequence. Ninth consequence is that x into minus y is equal to minus xy, or these three statements basically they are saying minus x into y equal to minus xy, or minus x into minus y equal to xy. This is very trivial. We never think that this needs proof, but this needs proof. Okay. So basically, if you see this term minus xy, what does it mean? Minus xy means this minus sign denotes additive inverse. Additive inverse of xy is this x into minus y. Okay, so first we will prove that. How? And additive inverse की property हमारे पास क्या होती है कि अगर हमारे पास additive inverse, if A is an element and we can find an element B such that A plus B is 0, then B is called what? B is called additive inverse of A. ठीक है, additive inverse of A. तो it means अगर हम additive inverse को उस एलिमेंट में ऐड करेंगे तो हमें क्या मिलना चाहिए? Additive identity. Fine, you can just understand the concept and theory. So अगर हमें एक्स वाई का एडिटिव इन्वर्स निकालना है, हमें ये दिखाना है बेसिकली एक्स वाई का जो एडिटिव इन्वर्स है वो ये है एक्स इंटू माइनस वाई. तो हम क्या करेंगे? एक्स वाई का जो एक्स वाई दिस एक्स वाई को इस एलिमेंट में अगर हम ऐड करें और हमें क्या मिल जाए? 0, देन वी आर डन. तो लेट अस चेक द एलिमेंट एक्स इंटू माइनस वाई, एड एडिशन एक्स वाई. ओके, इक्वल टू नाउ we can take x out using what? Distribution law, and minus y plus y inside. This is we are using distribution law. ठीक है. Now inside bracket what is there? This is y and this is the additive inverse. So the result will come additive identity. Fine. ये आपका y है और ये क्या है? उस y का additive inverse. और प्रॉपर्टी क्या होती है? अगर हम एडिटिव इन्वर्स और एलिमेंट को ऐड करें तो हमें क्या मिलता है? एडिटिव आइडेंटिटी. सो इट विल गिव यू एडिटिव आइडेंटिटी. फाइन. तो ये आ गया 0 विच इज़ एडिटिव आइडेंटिटी. अब क्या हमारे पास हो गया? एक्स इंटू ज़ीरो. एक्स इंटू ज़ीरो अब हमारे पास क्या होगा? जो कि हमने इस रिजल्ट में ऑलरेडी प्रूफ किया है. एक्स इंटू ज़ीरो इज इक्वल टू 0 फॉर ऑल एक्स, दैट यू कैन यूज़ हियर. तो एक्स इंटू ज़ीरो इज़ 0. तो हैंस वी कैन से द एडिटिव इन्वर्स of xy is x into minus y. Okay, because just read the if a plus additive inverse minus a is 0, it means minus this, they are the additive inverse of each other. Now similarly the second proof is almost similar. Third we can see here minus x minus y. Start from this left hand side, minus x minus y. So minus x minus y, here I am using again this first result. This first result basically what it is saying, x into the first result is saying x into minus y is what, minus x y. दैट इज़ माइनस आपका बाहर आ गया और जो ये दो एलिमेंट बचे ये आपके क्या हो गए, प्रोडक्ट हो गए. ठीक है. तो अब अगर हम इसमें यही ये प्रॉपर्टी अप्लाई करें माइनस एक्स माइनस वाई में, यूज़ ईयर, तो ये आपके क्या हो जाएगा, माइनस ये फॉर्म जो आपका रिजल्ट में आया था फॉर्मूले में, और उसके बाद आपका ये जो दो एलिमेंट हैं वो मल्टीप्लाई हो रहे हैं. ठीक. तो यहाँ पे आपके एलिमेंट क्या है, ये जो x की जगह हमारा क्या है, माइनस एक्स, तो ये हमारा हो गया माइनस एक्स, और y आपका एज इट इज़. ठीक है. तो बेसिकली अब ये हमारे पास हो गया माइनस ऑफ, अब यहाँ पे हमने क्या किया है, माइनस एक्स इंटू वाई, ये जो हमारा आपका सेकेंड रिजल्ट जो अभी हमने कहा आप ट्राई करिएगा, माइनस एक्स इंटू वाई, दिस इज ऑल्सो माइनस एक्स वाई. सो यूजिंग दिस माइनस एक्स इंटू वाई आई कैन राइट इट माइनस एक्स वाई. फाइन. तो अब फ्रॉम हियर what is it is saying, it is saying that additive inverse of minus xy is same as x into y.